can call it a day. So this is real. Now here it is magnified. The other one, it is what? This is big.
It is beyond C.
It is beyond C.
The other one was white. When you
Lastly,
on heating turned yellow. On cooling it went back to white. Now the
inverted.
It is inverted. It is inverted. So those are some of the properties of the image. Yes.
Teacher, like the difference between laterally inverted and inverted. For laterally inverted,
Is in plain mirrors.
It's in plain mirrors.
Yeah, the horizontal inversion of an object. So it is the left appears on the right and the right appears on the left. So it is a horizontal inversion. Horizontally inverted. Now, let us finish this. I want us to finish this and we look at this, then we see it from here, from this point here. Let us look at C, object at C. Object at C. Aineviona? Aineviona? Aine? You took off. Are you from telling your friends? Okay. Object at C. Object at C. So object at C, we shall have this. And we shall have our principal axis there. Then afterwards, we shall have our, okay, this is the mirror. That's the mirror. Then we shall put our points, our good points. The first one is the principal focus. Second one is the center of curvature. This is the point. So we shall draw the image, the object, shall put it at C. And then we are going to start drawing using our rays. So the first ray is the one which is parallel to the principal axis. Like that. So after reflection, passes through the principal focus or the focal point. Like that. The other ray that passes through the principal focus
is going to the line water. What happens is that
like that is reflected as a parallel what?
Brown.
Reflected as a parallel ray.
Have you seen the milkiness there?
Now this one, try to see parallel ray.
Have you seen the milkiness?
Okay, like that.
Yes. If you have seen the milkiness, we are going back to what's finished.
Okay. So where they meet, that's where the image is, and they have met here.
So finally, this one has tested that. Okay. Finally, here we have seen that.
So if the nature is that,
now after knowing the gas,
one,
we now come back to
the nature of the image.
The solid and see what finally happens to the solid.
What's the nature of the image?
What is the color there?
The image is
brown.
At C.
Formed at C. Two.
Let's continue seeing.
It's inverted.
It's inverted. Three.
Now
it's real.
Finally,
it's real.
On cooling,
Four.
this is what happens. Yeah?
It's the same size as the object.
Yes, same size as the object.
Now
Same
you
size.
go to get it and cool.
Same size
After
as
cooling,
the
this is the end
object.
product. It is what?
Okay, that's at C.
Yellow.
Then beyond C.
So
now,
this one is different from zinc. Zinc turns from white
Let us finish everything, and I'm going to tell you the story
And then from yellow to gold back.
beyond
That's the behavior of zinc oxide.
the hidden meaning here, beyond
It's
C.
no longer zinc carbonate.
Beyond
it turns
C.
to zinc
So
oxide.
beyond C,
Now, when you heat zinc carbonate, it goes to zinc oxide, which is when hot is brown, isn't it?
okay, so we shall
From
put,
cooling it down to yellow.
we shall put
Then
this,
the other gas that is given. So when they ask you for the observation, you don't need the gas.
shall put that and that.
Because when you are heating,
So this is
gases coming out.
concave mirror. So this is the pole
Okay.
F and C. So if the image is placed beyond C,
Now, this one, we are going to talk on only.
that's beyond C, isn't it? That's beyond C, and that's our O object. Now first do the first ray. So if this one is 1 centimeter, even here should be 1 centimeter here, somewhere here, such that I can draw.
The gas is carbon dioxide, isn't it? So if you know that copper carbonate is like that,
That's the first ray, and this
you
ray
look at copper carbonate, you look at copper carbonate,
passes through that point, like that.
copper
Then the other one passes through this point from the top of the object. Okay, and then after reflection, after reflection, after reflection, after reflection, so here the image is formed. So we shall have that, and that is the image. Okay, so the nature here is that the image is, shall say, formed between C and what?
C and F.
C and F. It is also inverted. It is also real, but it is diminished. It is diminished. It is diminished. So diminished, it is not of the same size as that of the object. It is diminished. The size has reduced. And then lastly, object at infinity. Infinity. Object at infinity. Object at infinity. So what we are going to do is we are going to draw this and put this principal axis. We shall put our points. This is point F, point C, F, and C, and we shall draw this to the pole.
So when you are heating,
okay.
the first thing you are doing is to test for the gas that is coming out. Then after testing the gas,
Now, if we want to draw rays coming from infinity, those rays must be parallel. The rays that come from infinity are always parallel. Are we there?
Yes.
The rays that come from infinity are always parallel. They're always parallel. Now, I'll draw this first ray here, touching this point. Okay, this ray, like that, touches this point here. Now, this principal axis, which is here, will act as the normal, such that here the angle of incidence should give me the angle of reflection. So here I'm going to draw another ray which is being reflected, but it must be as if it is of the same angle. Are we together?
Yes, sure.
So you see the green color is disappearing. So when carbon dioxide disappears from this solid, the other thing turns to black. That is an oxide of copper now.
Okay, so that is the first,
Finally, carbon dioxide
the first ray, the first ray. Then the other ray,
you have seen the final solid color.
which is also parallel.
You see that solid?
So this ray is also parallel.
Black means that's an oxide of copper, which is called as an oxide of D and an oxide of what? Of zinc. So that is.
So if these rays are parallel like this, it appears, it means that they are coming from infinity. Now we should know is that if rays are coming from infinity, where they intersect is where the image should be. So they should intersect. The image should be here where the principal focus is. That's where the image should be located. So we shall do this.
Water vapor. This process of heating ammonium carbonate, what is the common name given to it? That the solid that stands from gases.
Okay.
What is the common
So at this point here, this is where we have the E.
A solid turns to gas,
The image.
and without changing the liquid state. How do you call that process?
So
Yes?
the nature is that
According
one
to Cynthia, when a solid
image
turns
is
to gas,
at F, isn't it? Then it is also
Yes.
real. It is also real. It is inverted, and it is also diminished. It is also diminished. So those are the those are the properties of the image formed by an object that is placed at infinity. Object at infinity. At infinity. That's the image. The image will be formed at F. This is the experiment that you can do for you to determine the focal length of a mirror by focusing a distant object. When you focus a distant object using a concave mirror, and when you use the screen, when you put the screen here, the image will be formed at this point. Now what you have to do is that to measure the distance between the screen and the mirror, and that distance is equal to the focal point, to the focal length is equal to the focal length. The distance that you measure from the screen to the mirror is equal to the focal length. So for you to determine the focal length of a mirror, just focus a distant object like a window. So once you see a clear image on the screen, and this image is upside down or it is inverted, then it means that that is the focal point of that mirror. Then measure the distance from the focal point to the pole or to the mirror, and that distance is what we call the focal length. So what have you noted when we looked at this kind of drawings? What have you noted? Because for me, I will give you my my find outs, what I've noted. For you, what have you noted? When we started from this side, when the object is placed next to P, it is virtual, it is inside. If it is at F, then it is at infinity. Are we together?
Yes.
If the object is at F, it is at infinity. But also, if the object is at infinity, the image is at what?
Yes.
Is at F. Do you get it? So if you place the object at infinity, the image is formed at F. And if you place the object at F, the image is formed at where? At infinity.
And if you place it at C,
When you place it at C, it is formed at C. Now, if it is formed beyond, if the object is placed between C and F, then it is this side now, it is beyond C. The more you keep on moving the object towards this side, the image comes nearer this side. Are we together?
Yes.
So unlike this one where the object is between F and P, the image is this side. But now, as you keep on moving it to this side, now the image goes at infinity. Keep on moving it to this side at C. I mean, between C and F, it goes here at C. The image comes here at C, like how we saw. If you put it at C, the image comes at C. Continue moving the object this side, the image will move this side. So now, if you place it beyond C, for it comes between C and F. If you place the object at infinity, the image is formed where? At F. So those are the things that you should note. And you should note this one very well.
So an image will never be formed between F and P.
Will never be formed between F and P. An image, it can be formed between F and P. Come again, you have said that?
Like that image being formed between F and
Yes. Cannot be formed between F and P. So it is always formed between C and F. And even if you put it at infinity, it will be formed where?
At F.
At F. So between F and P, we shall not have any image formed there. We shall look at where it is formed between F and P if we have composite mirrors, one mirror and another mirror. That's when you can have an image formed here. So we have already looked at the excuse me. We have already looked at the uses of concave mirrors, and these are the uses. Used as shaving mirrors, used by dentists for teeth examination, used as solar concentrators in solar panels, used as reflecting telescopes. Yeah, in reflecting telescopes, they are also used. Used in projectors and also in devices showing slides on the screen. So projectors use concave mirrors to concentrate that light from the lamp. So to concentrate it onto the slide such that you have the image. And lastly, that the advantage is that it forms magnified and erect image. This advantage is the reason why it is used by dentists for teeth examination, and also the reason why it is used as a shaving mirror. So if you want to know what a concave mirror is, go to the kitchen, get the cutlery, one of the cutlery. Is it called cutlery? The spoons, forks, and what? Are they called cutlery?
Cutlery.
Get the spoon, and then the bent part like this, let it face you, and then you see your image, how it will look like. That kind of, the inside of that spoon is what we call the concave mirror. It's the concave mirror in that case. Are we together? So I would like to end here because I started early enough, and anyway, we had also some kind of interruptions with the power and what, but let us end here. Next time when we start, we shall start with images formed by a convex mirror, derivations here, and later magnification. So you have a lesson at 9 of teacher Timon, the one of
Tomorrow.
Saturday.
Saturday.
In Mr.
At 9?
Yes, in Mr. Omoni's lesson. So we'll teach you physics 1. Is it okay?
Okay.
Yeah. Have a good evening, and may the Almighty God bless you and also bless me. Bye bye. See you in the next lesson.